Hello grade 11s and welcome to the fourth segment of Match Test Practice. Please take that down. So 4.1 states, which law states that every body in the universe attracts every other body with a gravitational force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers? Please note that this is Newton's law. Of universal gravitation. Sorry about that. So you need to know that Newton's law of universal gravitation states that every body in the universe attracts every other body with a gravitational force that is proportional to the product of their masses and inversely proportional to the square of the distance between their centers. 4.2 states, a communication satellite of mass 1,600 kilograms moves in a fixed orbit around the Earth. Earth exerts a force of magnitude 4084,38784 newtons on the satellite in order to keep it in the specified orbit. Calculate the distance in kilometers of the satellite above the surface of the Earth. So, the mass of the satellite, we'll call it M1, 1,600 kilograms. M2 is the mass of Earth, which is 5,98 times 10 to the 24 kilograms on my information sheet. Then the force is 4084, 38784 newtons. So you write the formula. F is equal to G M1 M2 over R squared. Then substitute 4,084 38784. Okay, forgive me for the lack of space. G is 6,67 times 10 to the negative 11. M1 is 1,600. M2 is 5,98 times 10 to the 24 over R squared. So R squared goes here and this goes here. We're going to have R squared is equal to 6,67 times 10 to the negative 11, 1,600, 5,98 times 10 to the 24, all over F4, 4084, 38784. Okay, hope that was clear. Sorry for my camera being out of focus. R is the square root of all of this, 6,67 times 10 to the negative 11, 1,600, 5,98 times 10 to the 24 over 4084, 38784. R is, where's the square root? I get 12,500,000 meters. That is the distance between what? Between their centers. Remember, the question states calculate the distance in kilometers of the satellite above the surface of the Earth. So we're going to say distance is r minus radius of the Earth, which is r is 12,5 times 10 to the 6 meters minus the radius of the Earth on my information sheet is 6,4 times 10 to the 6 meters. Answer minus 6,4 times 10 to the 6. 6,100,000 meters. Then in order to write it to kilometers, we divide by 1,000. 6,100 kilometers. Or you can say 6,1 times 10 to the power 3 kilometers in scientific notation. I know those steps may have been too hard, but it does require practice, and I hope that makes sense. Okay. So 4.3 states, an object falling freely near the surface of planet Mars experiences a gravitational acceleration of 4,9 meters per second squared. The mass of Mars is 6,5 times 10 to the power 23 kilograms. Roman numeral number 1 states, calculate the radius of Mars. So we have the gravitational acceleration, 4,9 meters per second squared, downwards, right? And then we have mass, the mass of Mars, which is 6,5 times 10 to the power 23 kilograms. So we go to the information sheet. Which formula are we going to use? Gm over r squared. What is G? 4,9, 6,67 times 10 to the negative 11. M is 6,5 times 10 to the 23. I always apologize for my lack of space. R squared. This goes here, this goes here. We're going to have r squared is 6,67 times 10 to the negative 11, 6,5 times 10 to the 23, 4,9. Okay, r is square root of all of this, 6,67 times 10 to the negative 11, 6,5 times 10 to the 23, 4,9. Space again, please forgive me, you know I always apologize. Okay, it's going to be square root of 6,67 times 10 to the negative 11. M is 6,5 times 10 to the 23, 4,9. Getting 29, 74551,93, 2974. Let's see. 2,97 times 10 to the power 6 meters. As you can see, 2,97, because 4 is an insignificant number, so the 7 stays as it is. Okay, hope that is clear, and I hope that made sense. Okay. Roman numeral number 2 states, what is the weight of the object on Earth's surface if it has a mass of 7.25 kilograms? Weight is mg, which is 7.25 kilograms. The gravitational acceleration on Earth is 9.8 meters per second squared. 7.25 times 9.8. 71.05 newtons. Weight always acts downwards. Okay. 4.4 states, distinguish between the mass and the weight of an object. So remember, the mass of an object is the amount of matter in the object. Remember, the mass of an object is the amount of matter in the object, whereas the weight of an object is the force with which the center of the planet attracts that object. Hope that is clear. The mass of an object is the amount of matter in the object and is measured in kilograms, while the weight of an object is the force with which the center of the planet attracts that object. 4.5 states, Mars has a mass of 6.5 times 10 to the 23 kilograms, and its moon Phobos has a mass of 9.75 times 10 to the 15 kilograms. If the magnitude of the gravitational force between the two bodies is 2.50125 times 10 to the 15 newtons, determine how far apart Mars and Phobos are. So we need to find the radius. On the information sheet, we're not given the radius of Mars or the radius of Phobos, so just need to find the radius, which is the distance between their centers, r. So it's going to be f g m1 m2 over r squared. What is f? 2, 50125 times 10 to the 15. G is 6.67 times 10 to the negative 11. M1 is 6.5 times 10 to the 23. M2 is 9.75 times 10 to the 15 over r squared. This goes here, this goes here. So we're going to get r squared is 6.67 times 10 to the negative 11, 6.5 times 10 to the 23, 9.75 times 10 to the 15 over 2.50125 times 10 to the 15. So r is the square root of all of this, 6.67 times 10 to the negative 11, 6.5 times 10 to the 23, 9.75 times 10 to the 15 over 2.50125 times 10 to the 15. Okay, hope this is clear. forget times. Negative 11, 6.5 times 10 to the 23, and then 9.75 times 10 to the 15, 2.50125 times 10 to the 15. Sorry. Okay. 13 times 10 to the power of 6 meters. So you can just write it as okay. Hope that is clear and I hope that makes sense. I know that the steps are a bit too hard because of my lack of space. Please forgive me, it is important that you understand. Look at my sweat. Sorry. This is part 5. Please take down what you can. If you found this video helpful in any way, please click the like button and subscribe for more content. Thank you very much, and I hope to see you again.